We can only multiply two matrices if the number of rows in the second is the same as the number of columns in the first. For example, we can multiply a 2 by 3 matrix and a 3 by 2 matrix, but a 4 by 3 matrix times a 2 by 3 matrix is not possible. It is important to note that the matrix multiplication is not commutative. So if we have an m by n matrix and an n by l matrix, then we can multiply them, resulting in a matrix which is m by l. To multiply two matrices, we take the first row of the first and multiply this by each of the columns of the second in the way shown. We then repeat for each row of the first matrix.
The identity matrix is an n by n matrix where all the entries are 0 except the diagonal from top left to bottom right, where all the entries are 1. When another n by n matrix is multiplied by this, it remains unchanged. You can easily check this yourself. The determinant of a matrix A can be written in two ways: det of A or modulus of A. The formula for a 2 by 2 matrix is AD minus BC. For a 3 by 3 matrix, we first take the top left value and, eliminating its row and column, make a 2 by 2 matrix with the remaining values. We then multiply the top left value, A, by the determinant of the 2 by 2 matrix. We do the same with the top middle value, B, except we multiply the determinant of the 2 by 2 matrix by minus B. Next we take the top right value, C, then do the same method to find the determinant of the 2 by 2 matrix and multiply this by C. Lastly, we add all three values together.
We can find the inverse of a square matrix with non-zero determinant. There's more than one way to do this. Firstly, we find the determinant of the matrix. If the determinant is 0, then stop, there is no inverse. We then arrange the matrix in an array, with the matrix on the left and the identity of the same size on the right. Then, using row operations, we reduce the matrix to the identity. The matrix now on the right-hand side is the inverse. You can check this by multiplying it by the original matrix. I know this procedure seems very complicated, but an example will clear it up. Look at the matrix. We firstly work out its determinant. In this case the determinant is -1. This is non-zero, so we can continue. Now arrange this in an array. The matrix is on the left and the 3 by 3 identity is on the right. Next we use the row operations to reduce the matrix to the identity. Firstly, we get a new row 3 by taking 3 lots of row 1 from row 3. Notice on the left-hand side of the array I have noted down the computation. This way you can keep track of the sums you're doing. Next we get row 2 by taking 2 lots of row 1 from row 2. We can interchange rows. Here we interchange row 2 and row 3. Here we are multiplying row 2 and 3 by -1. I won't talk you through the rest of the row operations, but make sure you go through slowly and understand each step. So the matrix on the right is the inverse of A. Check it yourself by multiplying them together. You should get the identity.